Hello, Geography 232 students. Welcome to week 14 of our class. This week's lecture is part 2 on Python scripting. If you'd like to go back and watch part 1, it's available on the YouTube channel. So go ahead and click the link down below and you can watch part 1, then watch part 2 when you're done. So this week we're just going to continue our kind of exploration of Python scripting. We'll talk a little bit about various techniques, including lists and dictionaries. Moreover, we're going to spend a little bit more time talking about the actual applications of Python within ArcGIS Pro. In this week's lab, you're going to actually develop your own little miniature Python script, which is actually an executable tool that you can run. And then we're going to talk a little bit about just the kind of mathematical, kind of calculator-like features that you can use with Python, and a few other little bits and pieces. So this is just going to kind of continue last week's Python lecture. And so without further ado, all right, the agenda for this lecture. This week's lecture is called Python Part 2. This week's lab will be Get Started with Python in ArcGIS Pro, and you'll actually be using Python in an integrated development environment in addition to ArcGIS Pro, so you'll be able to work with it in two different platforms, environments. Upon completion of this lecture and lab, you should understand the difference between programming and scripting languages, understand the utility of Python libraries, and understand how to edit Python script in ArcGIS Pro and in an integrated development environment. Quick outline, programming versus scripting, libraries and modules, data types, lists and dictionaries, and then basic arithmetic using Python. So I'll finish up with a couple of just basic arithmetic techniques that you can use, and basically the sort of utility of that is understanding what the different symbols mean when you're using multiplication versus exponentiation, when you're using the equal sign, which is used to assign variables, versus the double equal sign, which is equal to. So there are different kind of maybe non-intuitive or less intuitive applications of kind of familiar symbols when you're working within Python. So I'll explain those toward the end. All right, scripting versus programming. So programming languages and scripting languages are often used interchangeably. You'll hear programming and scripting, and the difference may just sort of fly right by without actually kind of settling and you actually thinking those are two different things. So all scripting languages are programming languages, but not all programming languages are scripting languages. The key difference is that programming languages require a compiler to convert into binary. Binary is essentially the language of machines, and it's a series of ones and zeros. So in binary, the phrase "this is binary" is 0 1 1 0 1 0 0, etc., etc. And so with a programming language, essentially it has to be compiled from the object-based language into something that a machine can understand. Okay, so that's really foundational. We call that like high-level programming. And with that, you can actually build entire programs, operating systems, applications, things like that. And so I'll explain the difference a little bit more in greater detail. Scripting languages do not require compilation and are interpreted, meaning they are interpreted through some sort of environment. Like, for example, with Python, Python is actually interpreting the script that you are inputting into it. So scripting languages refer to automating certain functionality within an existing program. Maybe it's Python, maybe it's JavaScript, maybe it's Ruby or PHP, one of those. So those allow you to essentially connect diverse existing components to accomplish new and related tasks. You can kind of think of scripting languages as like glue that allows you to stick together disparate or separate parts. And that'll make a bit more sense when I start to talk about libraries. So a few examples of scripting languages that are fairly common today and popular are Python, obviously, PHP, Ruby, and JavaScript, which is very popular for web-based scripting. Programming languages, in contrast, refer to the development of a new program from scratch. So you can think of scripting as being within the environment of a program that already exists, whereas programming is literally building a program from the ground up with that binary. Now you don't need to know the binary code, you need to know the actual programming language, which may be C or C++, .NET, COBOL is an older one. But those sort of high-level foundational programming languages then have to be compiled into binary in order for the machine to understand them. Those are known as system languages. So using scripting in ArcGIS. Esri introduced scripting support in 2004 with the introduction of ArcGIS 9.0, and initially they included Python, VBScript, JavaScript, JScript, and Perl. Over the years, Esri tended to favor VBScript and Python sort of equally, and the others sort of fell out. And then eventually, with the introduction of ArcGIS Pro, Esri promoted Python as its sole scripting language to the exclusion of the others. So that's when VBScript, JavaScript, JScript, and Perl fell out entirely. So scripting languages in ArcGIS are able to access all the functions available within the software, including extensions. So any sort of tools that you can use with the interactive, sort of WYSIWYG or visual interface-based tool access, like whether it be in a toolbox or from the geoprocessing dropdown, all of those are accessible using Python. So one other note there about ArcGIS Pro, just in the last few years, they've introduced what they call Arcade, which is sort of Esri's own. I kind of feel like Arcade is sort of an Esri customized version of Python, a very simplified version. And that may not be entirely accurate, but it's a very, very stripped down, very, very simple, but also very, very easy to use scripting language. And it's useful for customizing labels, pop-ups, running calculations, creating custom values or custom fields, where, like, let's say that you've got two different fields. One represents one numerical value, another field represents another numerical value. And if you want to see the relationship between the two, like maybe divide column A by column B, you can add column C and then calculate the field that way. Or you can use Arcade to run the calculation on the fly, then have that result or the calculation there displayed on the map, whether it be as a symbol, a quantitative value for symbology, or maybe a label, something like that. So Arcade is kind of an Esri specific distant cousin of Python, if you will, and it's, like I said, it's very simple and accessible. All right, so a little bit about Python libraries and modules. So Python scripting allows you to build large bodies of code by importing and connecting existing code blocks known as modules. As you can imagine, as I explained with programming, you are essentially starting from scratch. And when you do that, that's a very time-consuming process. It requires intensive study and practice. Obviously, people study computer science and major in these sorts of things. And so if that isn't your history or your expertise, scripting allows you to take code blocks in the form of libraries and modules and then essentially piece them together. And those modules already contain the vast majority of the code that you might need to accomplish X, Y, or Z tasks. So modules help speed up the process by using already existing code. And they are a fairly user-friendly sort of introduction to more, not necessarily complicated, but more comprehensive and usable modules that you don't necessarily have to type out yourself in the full extent. So large collections of modules are stored in libraries. Libraries contain collections of related modules. There are many useful libraries available, including Matlablib, Pandas, and Archipai. So I'll explain a little bit about Matlablib and Pandas, but those are just two of the more popular ones that I've used in the last year or so in the world of sort of data science. And then Archipai, as the name implies, is from Esri, and it's used within the ArcGIS environment, but you can actually import the Arcpai library into any IDE, any integrated development environment, as long as you have access, obviously, if you have it on your computer first. So Matplotlib, it's a popular library for generating data visualizations in Python. It supports basic two-dimensional graphs as well as more complex animated and interactive visualizations. These are just a few examples of what you can do with Matplotlib. And it's a very popular library for those who are working in data science. Another is Pandas. Pandas is also useful when you're working with tabular data. So data that may be in Excel or CSV or Access format, you can then import it into Python and then display what would typically be viewed within like a spreadsheet. You can actually view it in Python, and then you can run all sorts of different statistical analyses on the data. And so it's, again, a fairly user-friendly data library, and it allows you to really kind of explore the data in ways that you may not necessarily know how to do in the context of Excel or certainly outside of the GIS environment. And finally, we have Archipai. So the great thing about Archipai is that there's lots of documentation on it from Esri. The not so great thing is that it's not open source in the sense that you actually have to have an Esri license to have access to Archipai's different tool sets. So it's Esri's own Python library. It supports geospatial analysis, mapping, network analysis, and many other different modules. I have a couple examples there on the right: charts, data access, geocoding, image analysis, mapping, and so on and so forth. So there are many different applications for these different modules. All right, finally, a few more data types, sort of expanding on what I talked about last week. So in last week's lab, you were introduced to the concept of lists. And so I'm just going to get into that a bit more. So a list is a container that holds objects in a specified order. And if you think back to your week 12 lab, you were supposed to order individuals invited to a dinner party by height. And so those were all stored in a list. And as you should recall, lists are indexed by numerical values. So depending on the order of the object within the list, it's all assigned an index value from 0 on up. So a couple of examples here. We type objects separated by commas into brackets to create a list. So list 1 is an empty list, and this would be probably the first time I mentioned this to you, although you might have already noticed from last week's lab. Whenever you see those hash marks or the pound sign, that indicates comments. Comments are outside of the actual script itself. They are embedded in the text, in the transcript, but the actual Python script itself skips over anything that has those hash marks. So if you see those, that means those are comments to kind of explain what's happening in the script. So list 1, this is an empty list. You can see it's just brackets with nothing. List 2 contains 5 integers from 200 up to 204. And list 3 contains 3 superheroes, which are also strings in this case: Batman, Superman, and Wonder Woman. One thing to keep in mind, lists do not have to be homogeneous. They don't have to be all the same type. So list 5, we have an integer, we have a string, and we have a float value. So 201, Wonder Woman, and 3.14159. So, as I mentioned before, with a list, you access the elements in the list using an integer index. List indices are zero-based, meaning the first object in the list is indexed to 0. An example here would be print the second object in the list. So if list 5 equals 201, Wonder Woman, and 3.14159, then we say print list 5, that's our variable, indexed to the number 1 spot. That's actually the second value. So we would print it, and it would be Wonder Woman. That's the second item in the list. Another example here, print the value of pi. So we see there our third value is actually index number 2. So print the value of pi is space close quote plus list 5, that's our variable, or our list rather, and index to item number 2. So the value of pi is 3.14159, etc., etc., etc. All right, next up we have dictionaries. Dictionaries are similar to lists in the sense that they are collections of objects. The difference is that dictionaries are collections of pairs of items or objects, where each pair has a key and a value. So the key in this case could be, we'll say, height. Another key could be weight. Another key could be country. Whereas the value would be maybe 6 feet tall, the other could be 150 pounds, and the other could be Mexico, right? So height, 6 feet tall, weight, 150 pounds, country, Mexico. So key and value. Dictionary objects are contained within curly braces. That looks sort of like brackets, but with a little kind of curl. I think there's probably other names for it as well. Each key is separated from its value by a colon. So here's an example, personal information. So the roster is the variable. In this case, that's the dictionary name. And within it, we have a key of name, value, Bob, age, 16, eyes, blue. It looks like I'm missing the enclosing curly brace there on the right, so you just have to imagine it. And so then if we were to print that, we'd say print student name, so in quotes, print quote student name colon, comma roster name, and that would give us student name Bob, right? Because it goes to the roster is the name of the dictionary, and then the index in there, the key it's looking for is name, and then obviously its value is Bob, so it prints Bob. Print roster age, which is 16 years old in quotes, and then finally print eye color colon roster eyes, which are blue. So it's student name Bob, 16 years old, eye color blue. And you can actually type the script into your IDE or ArcGIS Pro and see it work for yourself. All right, so last thing I want to kind of follow up with is basic arithmetic in Python. And so obviously it's fairly simple and straightforward, and sure, you could do this on a calculator, and that would probably be more practical. But what I want to do is introduce just the concepts of, I guess there's like one or two key different uses, or I guess unintuitive applications of commonly seen or commonly used symbols. So with addition, it's a plus sign, obviously, and it's intuitive in the concept of working with numbers, right? So 25 plus 10 is 35, we know, but you can also use the plus sign to concatenate. Concatenation is just the joining of different words or strings together. So you could do quote pi, close quote, plus quote thon, close quote. So if you add those together, it concatenates Python together. You can also concatenate let's plus go, but notice there's a space before go. So let's plus space go, and the result is let's go. And notice in that case there is an apostrophe, right? So in Python, whether it's apostrophes or quotes, you can use them both to identify strings. But if you ever need to use an apostrophe in the actual wording, make sure you use the double quote to differentiate between the two. Subtraction, pretty straightforward. 25 minus 10 is 15. Multiplication, now obviously you can do it with numerical values, like 3 times 3 equals 9, but you can also multiply strings. And again, they repeat in this case. So pi times 3 equals pi, pi, pi. All right. Division works out, because Python is object-based, it can identify what the numerical type is. Is it going to be an integer, or is it going to be a floating number? In this case here, the first, because it has a decimal place, 3.0 divided by 2, Python knows that it's going to be a floating number. Okay, so it's floating to one digit, and that will actually give you the actual result, which is 1.5. If, however, you do 3 divided by 2 without a decimal place, it actually rounds to the nearest digit, and it rounds down in this case. So 3 divided by 2 is 1, even though there's a remainder of 0.5. So those are a little bit different. And then finally, exponentiation. So if you want to do an exponent, which is typically a caret key when you're in a calculator, it's actually 2 asterisks or multiplication signs together. So 3 to the second, or 3 squared, equals 9, right? 3 times 3 equals 9, but it's not the caret key, it's 2 asterisks together. Then a couple other sort of unique cases in Python. We can do comparisons, right? And so the symbols that we use for comparing may not necessarily always be intuitive. So my examples here are 3 is less than 5. That's a true-false statement. Is 3 less than 5? Yes, it is, so true. And then here's another one that is not necessarily typical outside of the environment of scripting. So in this case, if it's an exclamation mark and an equal sign, that is not equal to. Okay, so 3 is not equal to 5. True, it is not equal to 5. And then here we have 2 back-to-back equal signs. That's telling you that it's a true-false statement of equals. Does 3 equal 5? No, it does not. So it's false. Okay. And the next example, greater than or equal to, is 3 greater than or equal to 5? No, it is not, so that's false. And then you could also do multiple comparisons. In this case, we have 1 is less than 3 is less than 5. Those are all true, so it's a true statement. So the thing I just wanted to point out was that a single equal sign is used for a variable assignment. Okay, so the example here would be x is equal to 12. You're assigning the value of x to 12. Okay, if you have 2 equal signs, that's for comparison. In that case, it's saying 12 is equal to 12. True, right? If we did 12, then 2 equal signs is equal to 11, that would be false because that's not equal. So just know that if you use 2 equal signs, you're actually doing comparison of 2 different values. If it's 1, you're doing a variable assignment. All right. So that sums up this week's lecture. Make sure to complete this week's lab. This is actually our last lab for our class. So what I'm looking for this is a screenshot of your countfeatures.py Python file. Once you've actually created it, just take a screenshot of where it's located in your folder. And then also I want you to run the Python, the script itself. Show me the results after you've actually run the tool in the shell, so I can see it should look something like that. So I want to see the actual Python file, and I want to see the output. All right, so on that note, have a great week, everyone. Reach out if you have any questions. Bye-bye.